right, let's see if it works. All of our mask streamers today.
Where's my band?
Wait, there you go.
I'm afraid I'm gonna break these straps. It's just gonna fly off my head.
There we are.
Oh my. Okay.
All right, we are live, and we'll see if anyone joins us. We're talking about weird animals today, so we'll see. Oh, we have 2 people. Hi! We're talking about weird animals today, but we're gonna wait to see if anyone else wants to join us today. It's gonna be, oh, cool, more folks.
Table.
Yay! Can everyone hear us? Where's your sign?
Right here.
Oh, look, can you hear us?
Oh, you can't read it though.
There we go.
Can you hear us?
If you can, write something in the comments for us. I'm a little rusty. I'm the one who did this last month, and I'm a little rusty doing these. Doing the earrings.
Oh, I do. Are they snakes?
Mhm.
Oh, they are snakes.
Alright. Oh, 11 people.
Cool.
Sweet. Alright, my friends, we are going to go ahead and get started. Morning, Nyoka. Nice to see you. I hope everyone is having a good summer. It's been pretty crazy here, but we are almost through. We're in August, which is insane, and it's almost fall already, so don't know how that happened. Time's really weird, but we are going to get started. Yay, thank you for letting us know you can hear us. Perfect. We are going to talk about weird animals today because if you haven't noticed, our theme for social media this month is weird animals. So on Instagram, we're talking about weird anatomical features, which is pretty cool. On Twitter, weird animal behaviors with Emily. And then here on Facebook, we're talking about, weird mammals like
The platypus!
the platypus. We're also talking about weird scientific names because that's really fun. A really fun one this week. And then weird animal, just facts about ZooMontana animals, which the turkey vulture one was my favorite, and it was great this week. So definitely keep an eye on our social media. We got lots of cool things. But for our Facebook Live today, we wanted to chat about what is weird, right? Because everyone has different definitions of the words, as we talked about with what is a word, but also weird can mean a lot of different things. And in our posts, we're kind of covering any of these different definitions of weird. So weird can mean extreme. So if you haven't heard of a tardigrade, I'd recommend looking them up. They're also known as water bears. Water bears! They're like 1 millimeter to 1.5 millimeters long. They're super microscopic animals. They literally live all over the planet. There's over 900 known species. They have been found at high elevations in the Himalayas. They've been found in Japanese hot springs. They've been found in Antarctica. They've been found in the desert. They've been found bottom of the ocean. They literally have also, they put them on a satellite and then shot the satellite to space.
And they were fine.
And most of them came back, and even some of the females had even laid eggs. Like, they were fully exposed to the radiation and the cold and all that stuff that would kill us in 15 seconds. But yeah, they were fine. They were chill. So that's, an example of a weird animal, right? Tardigrades. But it can also, the extremes can be like the Arctic or Antarctic animals. So, by the way, in case you're wondering, on land, the coldest temperature recorded here on Earth was negative 128 degrees Fahrenheit, which was in Antarctica at the Russian Vostok station, I believe. And most animals, however, tardigrades, by the way, can live in those areas. Really crazy. But most animals that live on Antarctica usually take to the oceans when it gets that cold out, because the ocean is relatively warm compared to being on land. But, if you ever had to take an ice bath, the oceans around Antarctica are typically between 28 to 35 degrees Fahrenheit. So it's, not exactly warm. And, water also conducts heat. I think that's the right word, conducts heat faster than air does and better. So theoretically, being in the water, even if it's warmer, would make you colder faster because it takes away your heat. However, Arctic animals get around this by having blubber, which means that their skin level temperature might be the same level as the cold around them, like 28 to 35 degrees Fahrenheit. But even a couple centimeters in past the blubber, their bodies are at 100 degrees Fahrenheit. So blubber is a really great insulator and helps Arctic animals survive those extreme temperatures. Now, animals in deserts. So there's some really crazy, the highest temperature ever recorded on Earth, on land, is 157 degrees Fahrenheit. So both of these are too hot and too cold and just too much for humans, right? But There's literally a fish, a species, a group of genera, I think, of fish. They're called pupfish. And some of them live in Death Valley National Park, and some of them live in Mexico. And in different places there, their springs, like their water, reaches 115 degrees Fahrenheit.
Oh my gosh.
It's like a, it's a hot tub, right?
That's.
But like the animal lives there, so like they're in the 115 degree weather or temperature all the time, and again, hot. But like these fish can live in that, which is insane. Most fish can't live in temperatures that high. On land, the hottest we already talked about hottest temperature recorded, which is 157. That was in the Iran Toon Desert, I believe. Did I say that? Tool? I forgot which one it was. I didn't write it down. But the Rupel's fox lives there in Iran, and they come out at night, but during the day, temperatures can be 120 to 150 degrees, depending on the time of year. No big deal. These animals survive this extreme temperature. They have a really low metabolism. Their bodies are small, so they don't need as much. They also have really big ears to let off heat. That's how they survive these extreme temperatures. And of course, Australia, because you can't talk about extremes without talking about Australia. Some places in Australia also compete with Iran, with their daytime temps being in the 120 to 150 range. The greater bilby, which is a really cute, like, wallaby-esque animal, I believe. They're super cute, but those guys survive those high desertish temperatures by digging underground. They can be as far as like 7 feet deep into the ground and dig like 10-foot tunnels. So that's how these guys survive. So that's one way that weird can mean. It can just mean something extreme, right? And there's so many more like bacteria and small single-cell organisms that live in even more extreme environments. But these are just animals that we're slightly more familiar with. Extreme can also just mean different from people. And weird senses are kind of the way I went with this one. For example, American kestrels, a really cute little falcon that's usually like this big. Here in the United States, they can see into the UV spectrum, which, by the way, rodent urine fluoresces in the UV spectrum, so they can watch the trails of rodents and fly down and catch them.
Isn't the UV spectrum the light that like gives us sunburn, like UVA and UVB,
yes.
So they can see that kind of stuff?
Yeah.
Weird!
Yeah. Cool, right? Mantis shrimps, you probably heard of. I had to include them because they're super cool, right? So we only have 3 color receptors, red, yellow, and blue.
Red, blue, and green.
Isn't yellow and blue mixing equal green?
Yes, red, yellow, and yep.
Red, yellow, and blue is the only color receptors we have. We can't see in the UV spectrum. We can't see polarized light. But mantis shrimps have 16 color receptors. Surprisingly, they don't use a lot of them for seeing color, but they actually can see polarized light, which is super weird. And this is my favorite one. This is one that Emily found out for one of her first YouTube videos. By the way, if you haven't checked out our YouTube, you definitely should. Emily's put up a lot of amazing videos, and she's going to keep doing so, and we're going to keep putting these up on YouTube as well. We're just going to keep going. So anyway, check it out. But she did an animal senses video, and she realized, or she found out, researched, that dog senses of smell is about 10,000 to 100,000 times stronger than ours. Okay? So that's kind of hard to visualize or conceptualize for us, right? Oh, this is a dog.
Yeah, this is this is the domestic dog replica skull that we have, and the part of the skull that animals use to smell is obviously right there. That is their nose, and the stuff that's inside their nose, the stuff that kind of looks like a brain, those are called nasal turbinates, and that's what gives animals their extreme senses of smell, or poor senses of smell, depending on where you fall on that spectrum. But as you can see, their nasal turbinates are extremely creased. They look almost like a brain, and the more elaborate the nasal turbinates, the better of a sense of smell an animal's going to have. So this is the nasal turbinate of a dog, and these turbinates are going to go all the way through this nasal passage right here, and the more surface area you have in the turbinates, aka the more folded they are, the better sense of smell they will have.
Yeah, and we did a short video about that with our wolverines a while ago too, also on YouTube. All right, my friends, now according to NOVA, which is a really cool place to research, in terms of vision, so that would mean like, the 10,000 to 100,000 times better than ours. If we can see something clearly at about a third of a mile away, that means a dog could see something clearly from 3,000 miles away.
That's how
so like
good their sense
farther
of smell
away than the
is.
United States is long. So yeah, that's how good their sense of smell is if we put it in like visual comparison. So
Which is insane.
amazing. So weird can also mean very different from people, right? And some of our posts are all about that as well.
Mm-hmm.
But even people have weird things about them.
Yeah, which often we don't think about. When we think about weird, we think of ourselves as like the standard, like we are normal. This is what senses should be. That's not the case. Our senses and our adaptations and our weirdness as a species sits on like this spectrum of weird. But because we are a very anthropocentric species, we kind of compare everything to ourselves. But let's talk about some weird things about us. So we are pretty cool, right? Our species is Homo sapiens, which are part of the Homo genus, which are descended from primates, including apes, right? So we are one of the only truly bipedal primates, meaning we are the only primates that walk upright on two legs the whole time. But this isn't the case with other living primates, and thus scientists can infer that this wasn't always the case with our ancestors. Fossil evidence shows that our ancestors originally were quadrupedal, walking on all four limbs, and then eventually becoming bipedal, which we'll talk about in a little bit why that helped us. But if you're shifting from walking on four legs to two legs, your body structure is going to have to change to accommodate that movement. And that includes the shape of our pelvis, which we don't have a human pelvis or primate pelvis in our biofact collection, but we do have the pelvis of an ungulate. So this is the spinal column in vertebrates, and it ends here in the pelvis, and it's the same in other vertebrate species as well, just with slight anatomical differences. So the pelvis here, if this was on a living creature, they would have legs attached to the bottom, and this is a quadrupedal animal, so it looks like this in reality. Our pelvis is upright like this, and this space in the middle, where my hand is, this is the birth canal. So if you're a female, this is where you are going to push a baby out of. And the shape of that birth canal will change with whether or not you are quadrupedal or bipedal. Now, when you are a quadrupedal primate, the fossil record has shown that your birth canal is larger or wider, meaning it can encompass a larger head, which is initially great for us because we have huge heads compared to our body size.
Shout out to all the moms out there.
Things change when we become bipedal. The opening of the birth canal actually constricted with bipedal movement, but our heads didn't get any smaller, right? Our heads continued to grow as our brain sizes continued to grow as our brains became more and more complex, which means we had a smaller pelvis to head ratio, which made birthing challenging, to say the least. And the fossil record shows that about 2 million years ago, this is when this pelvis structure change occurred, which means that at that time in human evolution, we would probably start to need assistance with birth to make sure that the mother or the child didn't have health complications or perish, right? Which means that the practice of like midwives and being doulas is approximately 2 million years old because of our locomotion.
That is so cool.
Which is crazy.
Shout out to midwives and
Which is
doulas
crazy.
and
So
moms.
shout out to all of you mothers out there who have pushed a large-headed baby through your small birth canal. I salute you.
That's
That
amazing.
terrifies me. Which, that's super, super cool. Now,
And weird.
and weird.
Because
And
most other
very
animals
weird.
don't have the issues that we do.
No, most other animals just sit there and they're like, yeah, cool, all right, I birthed a baby out, it's been 10 minutes, I'm chill, I'm fine, I'm good to go, and we're over here laboring for 8, 10, 12,
24
24,
hours.
36 hours in immense pain, all because we had to have giant heads and walk
Small
upright. So yeah, other things about us that are kind of cool and crazy are these dudes right here. Our opposable thumbs, which you can argue allowed us to take over the world. Now, we are not the only species with opposable thumbs. There are some groups of Afro-Asian primates, or your old world primates, that have opposable thumbs as well, but there are some characteristics about our thumbs that are pretty weird and pretty unique to our species, Homo sapiens. So our thumbs, compared to the rest of our digits, our fingers, are longer than other primates. This extra length in our thumbs compared to the length of our other digits allows for more grasping range and for more grasping strength. So while other apes like chimpanzees, orangutans, and even some monkeys, they can grasp things, they can hold things, and chimpanzees and other apes have shown, tool usage in the wild, but they don't have the versatility that comes with having a longer thumb. And it's that versatility that comes from having a longer thumb that's allowed us to develop more complex tools and stronger grip strength, that has allowed us to create machines and weapons and all these other things that have helped us to outcompete other animals. Now, what exactly makes a thumb opposable? Because there are animals that have thumbs, and then there are animals that have opposable thumbs. Now, an opposable thumb is classified as opposable when you can touch the other digits on that appendage, which means we can take our thumbs and I can touch my pointer, my middle, my ring, and my pinky finger all with my thumb. So it's that movement that makes a thumb opposable.
Cool.
Now, chimpanzees and apes, they can move their thumbs independently like we can, which technically makes it an opposable thumb, but they can't touch every digit because it's not as long, right?
That's cool.
Now, the one other thing about us that's pretty special, we don't really exhibit it anymore because we live in houses and we have machines, and when we forage, it means going to the grocery store, not hunting. But in our early evolution, right, we had to hunt down our protein, our meat, right? And that was one of the, meat consumption is one of the things that scientists and anthropologists think contributed to our huge brain sizes because meat is incredibly rich in protein and other nutrients. Now, to get that meat, we had to catch said meat, which means we had to track that animal. And we did it with endurance or persistent hunting, which means we would just follow it.
Because we're too slow to keep up with most of it. We're a lot smaller than most of our food sources were.
And we don't really have any weapons on our
We're not that
bodies,
strong.
right? Like, we're not that strong, we don't have claws, we don't have sharp teeth, like, we don't have these adaptations on our body. We have to make them. Think bows and arrows or guns and things like that that make us strong and powerful. So this ability to be an endurance hunter and literally just follow an animal to exhaustion is something very few species do. There's a couple predators that do that now. I think hyenas are endurance hunters. Many canine species are endurance hunters as well, like wolves or wild dogs. But their tracking doesn't really last multiple days.
Right. They just give up and find something
Human
else.
tracking historically, has lasted multiple days. And this ability to endurance hunt and have the anatomical body features that allow you to follow an animal for that long of time, right? Having a strong heart and the ability to, just keep going, the muscle memory and the, fibers and the strength to do that without perishing or just being like, I can't do this anymore. Like, that's a really cool adaptation to have that not many other species do, which makes us a really weird, somewhat hairless, bipedal ape
Animal.
that's just strange.
So basically, weird can mean anything. We're using it really to talk about really cool and fascinating facts across our social media. And today, we do have 2 live animals to show you today, talking about why they can be weird. So our first animal is a classic. Everyone loves her. And I'm pretty sure you guys have met her before. I think we've had her on a couple of programs, but she's one of my favorite outreach animals to use in general, whether that's here on Facebook Live or in person at our amphitheater programs or on outreaches, because not only is she super stinking cute, but she has a couple, well, more than a couple, adaptations that make her strange. Oh, excuse me. Her literal genera is Xenarthra.
Yeah.
Which means strange animal.
So this is Bandy. Bandy's our 3-banded armadillo here, and because you have met her before, we're going to keep her little weirdness short and condensed, but you can always drop questions in the comments. So she is an armadillo. You can see that one of the characteristics of armadillos is that armored shell. Now, we've talked about our other shelled animals that we have here at the zoo, which are our 3-toed box turtles. And turtles are unique and strange in the way that they're the only animal whose spine is fused to their shell. So we actually have a replica or example of that here. So inside a turtle shell, it's going to look like this. The spinal column goes down the middle, and all those ridges on the sides, those are their ribs. So their back is quite literally fused to their shell, meaning turtles cannot leave their shells at all, or it would take their spine with them, which does not sound like a happy, fun time. No. Armadillos also have a shell, but their spine is not fused to it. Now, they can't leave it, so if Bandy was just like, I don't want to be here anymore, she couldn't leave her shell and grow a new one. That shell is still attached to her body, just not via her spine. Her shell is a bony covering covered in keratin, which is the same stuff that makes up your fingernails or your hair, there it is, or rhino horn. But her shell is flexible, right? Turtle shells aren't flexible. It's flexible because of those 3 bands on her back that allow her to stretch her shell up nice and wide or curl it up into a ball. Now, she's one of the only shelled mammals, right? Bandy is a mammal, just like us. When we think of shelled animals, we think of reptiles like turtles, but she's actually one of the only shelled mammals. Armadillos as a group are one of the only shelled mammals. She has a relative in the United States, the 9-banded armadillo, which is named because they have 9 bands on their back. They're much bigger than Bandy, about 3 times-ish the size of Bandy. They live in like Texas and other states in the southeastern portion of our country. Now, my favorite fact about these guys is another way that they defend themselves from predators. So that shell we talked about is bony, right? It's going to be hard. It's going to be a good defense. So she can roll up into a ball to keep herself safe from predators that way. But if that does not work, they have something else up their sleeve. It's so weird. So, if she feels super threatened or super scared or stressed, armadillos have the ability to jump vertically 6 feet in the air, which is about half a foot taller than me. The anatomy behind this behavior, I have no idea how it works, but I think it's absolutely amazing. The function of this is basically like, okay, if my ball doesn't work, I can just confuse you and startle you, and maybe you'll just go away. And honestly, if I was a coyote or a puma or a bird of prey, and whatever I was trying to catch just like went from a ball to leaping 6 feet vertically in the air, I would just be stunned, and I think I would call it a day and go home. So armadillos are difficult to have as ambassador animals because if they get stressed, they can leap 6 feet out of your hands into the air, which, you know, when Bandy goes like this and does her cute little stuff, like, she's excited, but she's actually a fairly calm armadillo because she's not over here jumping 6 feet in the air, which is absolutely wild. One more cool thing about this group of animals, as Katie mentioned earlier, they're in the group Xenarthra, which includes armadillos, anteaters, and sloths. So, when our sloth friend is on exhibit, his closest relative in the entire zoo will be Bandy right here. So those are the only 3 living groups of animals that make up Xenarthra. Now, historically, I think it was back in the Pleistocene, armadillos were the size of a Volkswagen Beetle, which is insanity. And their shells were so big that humans actually used them for shelter. There's evidence of our human ancestors using these shells as shelter. Now, these animals were probably too big for our ancestors to go out and hunt. It'd also be extremely difficult to hunt an animal covered from head to toe in armor that's the size of a car. Yeah. So it's hypothesized that any of these shells that the humans used for cover, they scavenged. So basically the armadillo had died of predation or other natural causes, and the humans were like, hey, that looks like a really awesome home that'll keep me warm. Let's take this back to our village and let's live in it. So that's a crazy, cool, weird fact about the ancestors of Bandy here. And our sloth friend, Winston. And cool fact about sloths. So we all know they're pretty slow critters, right? They're not known for their speed or their agility. And their slowness goes all the way to their intestines. Their bowels are very slow. They only poop once a week. And sloths are arboreal, meaning they live up in the trees for most of their life. But when nature calls once a week, they will go down to the forest floor and poop. And they poop once a week, and it's a very long process. Apparently, it all comes out with one push. And I was reading articles on this. Apparently, scientists observing sloths pooping can literally watch their stomach size decrease as they poop out a week's worth of plant material. But because it's such a long process and probably requires a lot of focus on behalf of the sloth, half of all sloths die while pooping because they get eaten because they are so focused on pooping once a week on the forest floor.
Wow.
So there you go.
By the way, sloths didn't used to be that vulnerable, maybe is the word we're looking for. There used to be dozens and dozens of different species, and they were super adaptable. Some of them lived in mountains, some of them lived in the ocean, and some of them lived in rainforests on the ground. There were giant ground sloths, too. So there's a lot of diversity in sloths. You should check out PBS Eons. They have a video about when sloths were in the sea, or how they went from the sea to the trees or something like that. Super cool. Definitely check it out. I watched it today and my mind was blown. But, as you guys have noticed, we have a lot of snakes here at the zoo. Snakes are super weird, right? They're super cool. They're also super weird. in the way that they're different from a lot of other animals in so many ways. And we don't even have time to talk about all those ways today, but we're going to talk about mesa here. Mesa is a gopher snake or a bull snake. Quick fact, if you've seen bull snakes here in Montana or in the area near us, right, or in Wyoming, chances are you've noticed that they're a lot darker than mesa here. Mesa here is technically a Sonoran gopher snake, so from the Sonoran Desert in Arizona. Bull snakes live through most of the United States. They just vary geographically what they look like. So in the Sonoran Desert, it's hot, right? You don't want to absorb any more heat than possible. So having lighter stripes means that they don't absorb as much heat from sun, just like wearing a dark shirt on a bright sunny day or wearing a white shirt on a bright sunny day. You're going to absorb less heat. That's why this guy doesn't have a lot of color, bright dark color on his scales. Versus the gopher snakes that or bull snakes that you find here in Montana, these guys in Montana are much darker and more distinct patterns because they need to absorb more heat. It's Montana and Wyoming. It gets a lot colder here, and they need to absorb as much heat as possible. Okay, so that's, first of all, just in this species, super cool ability, or, I mean, not ability, they don't do it on purpose, but geographically they look different because of the different needs of their environment, okay? Now, got some really weird things for you. First of all, snakes don't have ear holes, but snakes can hear, sort of. They retain the internal ear bones, and if they set their jaw against the ground, they can feel the vibrations of things walking along the ground and also just really loud noises because it vibrates inside their jaw, and they can send that to their ear bones. Okay, cool. Weird, right? But awesome. That's one thing that they retained the inner ear bones from their lizard ancestors. By the way, also weird, scientists still aren't sure which lizard ancestors snakes have. Their current theories, I think the monitor lizards, as well as a couple other different groups of lizards, but no one is really sure where they came from. Snakes evolved right later in the Triassic, I think. They were around when dinosaurs were around, but later in the time of dinosaurs, I think. If not the Jurassic, then the Triassic. Nope, Cretaceous is the
Cretaceous
last
is
one.
last.
There we go, Cretaceous. I always get this flipped. So snakes have been around a long time, but they're not quite sure which group they came from. Fun fact, if you like dinosaurs, check out all of our social media. Last month, we talked a lot about dinosaurs, and one of those posts on Instagram was about how mosasaurs, which are the big swimming dinosaurs, I'm going like this, that didn't have the long necks, those guys were related to lizards and snakes. Cool fact. Anyway, I can talk about these guys all day. I need to focus. What am I talking about? Okay. As most of you probably know, but I needed to talk about it because it's weird, snakes smell with their tongue, right? So talking about weird senses compared to humans, right, they have nostrils. The nostrils on the top of their head, they're holes, and they use those to breathe, right? But they use their tongue to smell. It flicks out, it gathers the smells in the air. It is wet, a tongue, kind of like most animals' tongues, I would assume. But it is a pretty wet tongue. It flicks out, and smells are just chemicals that are in the air. So it flicks out, grabs the smells that are in the air, and brings it back in. It has a vomeronasal, or Jacobson's organ, in their mouth that tells their brain, it's a sensory organ, it tells their brain what they're smelling. Super powerful. Not only snakes have this, many animals, like lizards, also have them, and some mammals even, like mice and rats. Elephants apparently have these. Dogs and cats and bears and cattle and giraffes, oh my. So a lot of animals actually do have these. It's not unique to snakes, but it just means they have an excellent sense of smell. Remember we talked about dogs earlier. Now the reason that snakes have forked tongues is because it gives more surface area. So if you think about it, a tongue that just looks like this only has the top and the bottom and the sides to gather smells, but a forked tongue has the top and bottom of two different sides and all the way around to be able to gather smells. So it's just more surface area to gather smells. It also can kind of tell them directionally which way the smell is stronger. So that's very helpful for them hunting as well. Now about breathing. This is one of my favorite things about snakes, among many other things, of course. But I said that they can smell with their nostrils, and they absolutely can. But if their mouth is full, getting their air in from the nasal passage isn't going to work very well. So, snakes have what's called the glottis, which in us actually connects to our voice box. But in snakes, it connects to their trachea, which is the breathing tube, right? So, when a snake has its mouth full, they can kind of move their glottis, it's like a straw almost, and they move it to like the side of their mouth so that they can still breathe when their mouth is full. Which is crazy. It's super weird to see and quite frankly terrifying. but it's really, really cool. So they can use that glottis, they move it so they can breathe, they chew with their mouth full, obviously they don't really chew, they move their food around in their mouth so they can swallow it whole, just like that. And we also have a video of that on our YouTube of Mesa right here eating a mouse. Yep, a mouse. So you can see his process of swallowing the mouse whole. But that glottis is movable. We can't do that, that's not a thing. But that way they can breathe while their mouth is full. Super cool. Now, last thing about that glottis, that's also how snakes make that hissing noise. They don't hiss. They don't make a hissing noise with their tongues. Their glottis has a piece of cartilage in it, and when they vibrate the glottis, it's how they breathe really heavy through it and vibrate the glottis, and that's what makes their hissing noise.
Huh. I didn't even know that.
I didn't know that until today either, so that was really cool.
Crazy.
So yeah,
Nature is neat, y'all.
Nature is neat. So that's how snakes hiss. That's how snakes breathe. We hope you learned something cool today. It was a bunch of random information. And this is our it today. So if anyone has questions, we'll be up here for about another minute or so. We are going to continue doing Facebook Live. You got to give us till at least September because we got busy with summer. But if you have cool ideas of what you want to hear about for Facebook Live, please let us know because we had a lot of ideas and then we used a lot of those ideas. So now we have to figure out what we're going to talk about. So I know that you guys have liked this, and we really appreciate everyone who watches these. But if you have ideas of what else you want to hear about, let us know. We've got, you've met most of our animals at this point, but we'll probably be bringing them back because there's always more to talk about. So if you have things you're curious about with nature, or with animals, or wildlife, or plants, or bugs, we will do our best. So definitely let us know. Definitely let us know any questions you have either about today's or any other topics you want to hear about because we're going to be brainstorming more Facebook Lives for the fall and winter.
Yeah.
All right, my friends. Thank you so much for watching today, and we will see you in September. Please stay safe, stay cool. It's too hot outside for me, but stay cool, and we will see you guys later. Bye.